Welcome to Your Math Explained, where we make math simple and clear. My name's Angela, and this is our first video in the trig series. Degrees are everywhere. 360 degrees in a circle, 90 degrees for a right angle, 180 degrees for a straight line. But when you move into higher level math, science, or engineering, suddenly everyone's using something else called radians. Why is that? Today, let's break down what a radian actually is, why mathematicians prefer it, and how it connects angles to circles in a natural way. And we're going to do that through this example here. We want to find the length of this arc in a circle of radius 1, and it's created by an angle of 60 degrees. So this angle here, let's call it theta, is equal to 60 degrees. So we know that the circumference of a circle is 2 pi r. And since the radius here is 1, the circumference here is 2 pi. So we can use proportions to find the arc length here. Since we know that the degree within a circle is 360, and this angle here is 60 degrees, that tells us the arc length A is equal to 60 degrees over 360 degrees multiplied by the circumference of the circle, which is 2 pi. So this works out to be pi over 3. So now the actual definition of a radian is that it is the angle formed when the arc length of a circle is equal to its radius. So using what we have written above, where we have arc length is equal to our angle theta divided by 360 degrees multiplied by the circumference, which is 2 pi r. If we want this arc length to be equal to the radius, then we would just say A is equal to r. So then we have r is equal to theta over 360 multiplied by 2 pi r. Now dividing r from both sides will give us 1 is equal to theta over 360 multiplied by 2 pi. And now solving for theta, we get theta is equal to 360 degrees over 2 pi. So if you actually put this into your calculator, you're going to get that theta is roughly 57.3 degrees. And that is equal to 1 radian. So this 57.3 degrees here is not what's important. The important part is this statement here. This actually gives us the conversion between degrees and radians. It tells us that 360 degrees is equivalent to 2 pi radians. So this means to convert between radians and degrees, we use the proportion 180 degrees is equal to pi radian. So when you need to convert from degrees to radians, all you need to do is multiply it by pi over 180 degrees. And then when you want to convert from radians to degrees, you multiply it by 180 degrees over pi. So let's go ahead and try that out with a couple of examples. To convert 30 degrees to radians, we will multiply 30 degrees by pi over 180 degrees. So then that gives us pi over 6. To convert 90 degrees to radians, we would take 90 degrees, multiply it by pi over 180 degrees, and that would give us pi over 2. And one more example, so 270 degrees, to convert that to radians, multiply it by pi over 180, and that is going to give us 3 pi over 2. And now, to convert from radians to degrees, we will multiply our angle by 180 over pi. So this would be 150 degrees. And then 3 pi over 4, multiply that by 180 over pi. And that is equal to 135 degrees. And then the last one, if we multiply that by 180 over pi, this is going to be roughly 257.8 degrees. So note, we usually leave radians in terms of pi instead of a decimal number. And notice how in our examples above, for degrees, we had this little circle here. But for radians, there's no units. So this means that if you don't see a unit on an angle, it means it's in radians. And then on most scientific calculators, there's a mode button that toggles between degrees and radians, usually denoted by the letter D and the letter R. It's very important to make sure that you're in the correct mode when working with problems involving angles, because if you're in the wrong mode, your answer will be completely off. So now the question is, why do we need radians? Well, let's go back to our very first example. We had our arc length, A, is equal to the proportion of the angle in terms of the entire circle, multiplied by the circumference, which is 2 pi r. But instead of using 360 degrees, let's see what happens if we actually use radians. Then we would get A is equal to theta over 2 pi multiplied by 2 pi r. And this simplifies to just theta times r. So the arc length of a circle is actually just the angle multiplied by the radius. This formula is much simpler than before and no longer requires unit conversion, because we have chosen to use the angle measurement that directly relates to the geometry of a circle. So now let's do a quick recap of everything we covered in this video. So degrees are man-made and convenient, but they're a little arbitrary and not very intuitive when it comes to circle geometry. Radians tie angles directly to arc length and radius, and that natural link makes formula in math, physics, and engineering much simpler using radians. So now it is your turn to give this a try. Can you convert these 3 angles listed here to the other measure? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on trigonometry in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.